All right, now let's talk about algebraic reasoning. When we go and we solve an equation, we use properties of real numbers. Segment lengths, angle measures, they're all real numbers. So we can use those properties to write logical arguments about geometric figures. So we're just going to go ahead and solve the way we've always solved, but now we're going to explain what we're doing. Okay, first thing, so we're going to solve 2x minus 5 equals 13 minus 7x. So the first thing we're going to do is we're just going to write down the equation. And our explanation is that's our given equation. Then we're gonna, we want this x is on the same side, so we're gonna add 7x, so we get 9x minus 5 equals 13. And we're gonna add 7x to each side. Then we need the x by itself. So we're going to add 5 to each side, and we get 9x equals 18. So we're adding 5 to each side. And x equals 2. Let's clean that up. Divide each side by 9. So we're just doing all the same solving we've always done, but we are adding an explanation to what it is we're doing. And this will be important going forward. It'll give us more ability to do bigger and better things. So let's look at our algebraic properties. So the addition property of equality. So if A equals B, then we can add the same number to both sides, and it doesn't change the equation. So A plus C equals B plus C. Same thing to both sides, didn't change the equation. Same thing we've done for a number of years now, going back all the way to middle school. So same thing with subtraction property. So if A equals B, then of course A minus C equals B minus C. Here C is the same number, both sides were legal. The multiplication property, starting with our real numbers A and B, A equals B, then A times C equals B times C. We haven't talked about these in a number of years, so that's why we're refreshing it now. So division property. So if A equals B, then A divided by C is the same as B divided by C. And we'll put these to use here in a few minutes. Substitution property. So if A equals B, then A can be substituted for B in any expression. This is where we plug it in. We solve for x, we get x equals 4 or some number, and then we plug it back into our original equation to find out what the total size of that angle or that segment is. That's substitution. And then our distributive property, well, we know if we have an A and then a B plus C, we're going to distribute just like so. So we have A times B plus A times C. And the same thing if it's actually subtraction inside the parentheses. You just end up with AB minus AC. The distribution process is still the same. So let's look why we had to revisit all these algebraic properties. All right, so 3x plus 2 equals 23 minus 4x. We have to start at the beginning, so we're going to write the equation. Oops. Because it's given. Then we want the x's on the same side, so we got 3x plus 2 plus 4 equals 23 minus 4x plus 4x. It's an x over there too that I almost missed. So what did we do? We added 4x to each side. And that's our addition property. All right, so next step in the process, 7x plus 2 equals 23, and we're combining our like terms. Which we call simplify. We simplified it. All right, so we got 7x plus 2 equals 23. Well, we want the x by itself, right? So we go 7x plus 2 minus 2 equals 23. Oops. Minus 2. And we're subtracting 2 from each side, which, oddly enough, is our subtraction property. Then once again, we're going to combine like terms, which is simplifying. And then divide each side by 7, which is the division property. We've solved for x. But now we want to check it, plug it back in, make sure we didn't do something wrong. So we got 3x and x is 3, so we're going to plug that in. Plus 2 equals 23 minus 4x. So we're substituting 3. So 9 plus 2 equals 23 minus 12. So 11 equals 11. That is true. We are doing well. Let's solve a couple more, write our explanation and reason, and we'll work on that. All right, so here I've written each step of the equation. So you're going to provide the explanation and the reason is all we got to provide. So the first thing, well, that's just writing the equation. The reason? Because it's given. We have to start with what we're given. Then to get from step 1 to step 2, we multiplied the -5. And what's that? That's our distributive property. All right, so down to step 3 here, we added 40 to each side. That's our addition property. And then we divided each side by -35 using our division property. W equals -2, and we are done. All right, so this next example, I've done the same exact thing. We laid out where the things that are going to happen. We just need the explanation and the reason. Go ahead and pause the video, work it out, and then I will show you the answers once you are done. All right, now that you've completed it, we should be able to go pretty fast. So we write our original equation because that is what is given to us. Then we're going to multiply out the 2. We're distributing, that's our distributive property. Then we're subtracting 2 from both sides. Our subtraction property. And then divide each side by 2 division property. Okay, good job. So let's talk about this one for a moment. Here, you get a raise at your part-time job. To write your raise as a percent, use the formula P times the expression R plus 1 equals N, where P is your previous wage, R is the percentage increase, it'll come out as a decimal, and N is your new wage. Solve the formula for R. And what is your raise written as a percent when your hourly wage increases from $7.25 to $7.45 per hour? Well, we're going to solve for R in the formula P times R plus 1 equals N. And anytime we solve for something, in this case it's going to be r, we're going to end up with r equals something. So we got to take the formula and make it so r equals, which is what we usually do when it's x. But sometimes when we add another letter in there, it short circuits us a little bit. So let's start at the beginning. P times r plus 1 equals n. So we're writing the equation because it's given. And we're going to move to PR plus P equals N. So we're going to multiply that P out and distribute it. That's our distributive property. Well, letters are just numbers, and if we treat them like numbers, we make our life pretty easy. So we can end up with PR equals N minus P, subtract P from each side. That's our subtraction property. And then we need r by itself, but it's being multiplied by p, so we got to divide. So r equals n minus p over p. Divide each side by p. Our division property. So now we are in a position to evaluate whether r equals r equals n minus p over p when n is 754 and p is 725. So we're just going to go ahead and plug it in. We're going to substitute 754 for n and 725 every place we have a p. So that's 0.29 over 725. So r is going to equal 0.04. We multiply that by 100. We got a raise of 4%. Again, only thing we're doing new is we're providing an explanation and a reason based in the properties of mathematics, properties of algebra. So here we got 3 more examples, but we're going to cut out the explanation and just go right to the reason. Right? We're just going to do it like we always have done it, and we're going to provide the reason, addition property, division property, simplification. Go ahead and work out all of the ones on this page, and then I'll walk you through the answer in the next video.